Hello, in this video we're going to be going into more detail on 8.2, which is arithmetic sequences. I did introduce this topic briefly in our introduction to sequences in 8.1, but arithmetic sequences are essentially a list of numbers that follow a pattern that all has a common difference. So for example, if I start with the number 7, I'm going to create a list of numbers that has a common difference. 17, excuse me. Maybe the next list in my numbers is 21, making the common difference here 4. So to get from the first number to the second term in my list, I added 4, which means to get to the third, I add 4 again, and then I add 4, and then I add 4, and so on and so forth. If this sequence is infinite, that means there is no ending and I just continue adding 4 forever, or it could be finite, meaning that I do end at a particular value, and maybe that value here is 41. So sequences can be infinite or they can be finite. We will be also writing the explicit formula for arithmetic sequences, meaning that I can determine exactly what the term in a given place in the sequence is using a formula. And then we're going to go ahead and recall just some notation for arithmetic sequences. So our first example, I'd like to talk about whether or not the sequence below is arithmetic. So take a moment, check these out, and decide if they are arithmetic or not. If so, go ahead and find the common difference. In A, I see that I add 1, which means if this is arithmetic, then I need to maintain that common difference and add 1 going from one term to the next for each term in my sequence. But going from term 2 to term 3, I see that I add 2, so automatically this is not arithmetic. In B, I see that from -3 to 1, I add 4. From 1 to 5, I add 4. So far, it's looking good. Let's just check the rest. 5 plus 4 is 9, 9 plus 4 is 13, so this is arithmetic. Since we are adding 4, our common difference is a positive 4. Here's an example where we're going to go ahead and write out the first few terms in an arithmetic sequence. So we're going to consider a woman who starts a small contracting business. She purchases a new truck for $25,000. So I'm going to go ahead and start with that $25,000. After 5 years, she estimates that she's going to sell the truck for $8,000. Assuming straight line depreciation, determine how much the truck will be worth each year over that 5-year period. So I've got $25,000. That's my first year, year 1. So year 2 is going to be worth a certain value, year 3 worth a certain value, year 4 it's worth a certain value, and then year 5 it's going to be worth $8,000. So we are adding a common difference, or the same number, each time in my list. So I'm adding that, I'm going to say common difference once, then I add twice, then I add 3 times, and then to get to the 8,000 I add 4 times. So I've got my 25,000, and I'm going to add on that common difference 4 times, and I will get 8,000. Now we are depreciating, we're decreasing in value, so hopefully we know that that common difference is going to be a negative number. We are losing value in our truck. And I solve my equation. 8,000 minus 25,000 is going to be negative 17,000. And then dividing by 4, my common difference is going to be 4,250. So in year 1, we know that it's worth $2,500. In year 2, we're going to be subtracting that $4,250, and we will end up with a value of $20,750. Subtracting that 4,250 again, I have a value in the third year of $16,500, and then subtracting 4,250 one more time, I have a value of 12,250 in the 4th year. So each year along the way, these are the values that the truck is worth. Writing terms of arithmetic sequences. In example 823, we're going to write the first 5 terms of the arithmetic sequence given the information below, And then in example 824, we're going to have a question that starts off very similarly to our truck example. So go ahead and pause and try out these couple on your own. In 823, my first term A1, this means the first term in my sequence is 17, and the common difference is -3. So if this is A1, then to get to A2, I subtract 3 and I have 14. To get to A3, I subtract 3 and I've got 11. To get to A4, I subtract 3 and I have 8. To get to A5, I subtract 3 and I have 5. So these are the first 5 terms in my arithmetic sequence. In this arithmetic sequence, I have my first term is 8, and I know the fourth term, so here's A1. I don't know 2 or 3, but I do know that A4 is 14. And they want us to find A5. So I'm going to go about this very similarly to what I did in the truck example. I need to figure out what number we are adding, and then I'm going to go ahead and add that number on to my 14. So I've got 8 is where I start, and I'm adding on that common difference here, 1, 2, 3 times to get to my 14. And then I solve. Subtracting 8, 3 times d is 6, which means that that common difference is 2. So if I want A5 then, the next term in my list, I need to add 2 to my 14 to get 16. So here A5 is going to be 16. So we found the common difference and then just continued our pattern to find the term that we want. Explicit formulas of arithmetic sequences. So just like we talked about in 8.1, what we're going to be doing is writing an equation to identify the nth term of an arithmetic sequence. Instead of writing your list out until you get to that nth term, we're going to have an equation that allows us to just plug in n and figure out what value that position has. So example 825. Given the first term of an arithmetic sequence is A1 and the common difference is d, write the first 4 terms. So here's A1. That's my first position. To get to the second term, I'm going to add d. So my second term is A1 plus d. Then to get to the third term in line, I need to add d again. So then I have A1 plus 2d. To get to the fourth term, I add d again to what I had before. So now I've got A1 plus 3d. So 1, 2, 3, 4. If I look, I'm going to go ahead and label these A1, A2, A3, A4. So to get to the nth term in my sequence, I am adding d one less time than the term I'm trying to find. So in A1, I don't add any of those common differences. Here, in my second term, I add d 1 time. In my third term, I need to add d 2 times. In my fourth term, I add d 3 times. So what we can say is that to find the nth term, I'm going to start with a sub 1 and add d 1 less time than that term I'm trying to find. So times n minus 1. And this would be our explicit formula to find the nth term of an arithmetic sequence. So given an arithmetic sequence where the first term is 17 and the common difference is -3, we're going to determine the nth term, or in other words, write the explicit formula for our arithmetic sequence. So a sub n is the first term plus the common difference times n minus 1. So a sub n is 17 plus my common difference, which is a -3 times n minus 1. And here is our equation. So we have a couple things we can do with this. Let's say I wanted to find the 20th term in line. I can start with 17 and then just subtract 3 over and over until I get to the 20th term in line. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, and so on. That would take a while and it would be annoying. Option 2, now that I have this formula, I can say let's just plug in the 20 and figure out what value I'm going to have in the 20th place. So 17 minus 3 times 19 and simplifying, we could find that value much more quickly and simply than we would had we been listing out all of those values. So our explicit formula helps us to identify the nth value in our list of our arithmetic sequence. All right, your turn. Go ahead and pause the video and try example 827 on your own. My explicit formula for A, I've got a sub n equals, my first term is 8, and then it looks like we're subtracting 7 times n minus 1. Now they ask us to find the number of terms in the sequence. This is something we haven't done before. So what I'm actually going to do is I'm going to say, hey, negative 41 is the last term in my sequence. So what I want to know is what's the n value. So I'm actually going to put my negative 41 in for my term, and I'm going to use that to solve for n. And then I'll know how many terms are in my sequence. So I subtract 8. Negative 49 is equal to negative 7 times n minus 1. If you want to distribute, you can. Negative 49 is equal to negative 7n plus 7. I subtract 7 from both sides. This gives me a negative 56 is equal to negative 7n. And dividing by negative 7, I find that n is 8. So what I have just found is that that term negative 41 occupies the 8th position. So I've got 1, 2, 3, 4, 5, 6, 7, and 8, which means that there are 8 terms in the sequence. For B, I'm going to go ahead and repeat this process very similarly, just with slightly different numbers. So I've got a sub n is equal to 6, and then my common difference here is 5 times n minus 1. There's my explicit formula. Now I know that 106 is the last term, so I want to know what n value that has. So I'm going to go ahead and put in my 106 for my a sub n, and then figure out what n value we're using to get there. We can simplify first. This is a slightly different approach than I did last time. 106 equals 5n plus 1. I go ahead and subtract 1 from both sides and divide by 5 to find that n is 21. So just like before in example A, we found out that that last term, 106, occupies the 21st position. So 1, 2, 3, 4, 5, 6, 7, all the way to 21. This is the 21st position, which means that there are 21 terms in the sequence. All right, go ahead and take a moment, pause the video, and try example 828 on your own. A woman decides to go for a 10-minute run every day this week and plans to increase the time of her daily run by 4 minutes each week. Write a formula for the time of her run after n weeks. So I've got 10 minutes the first week, and then the next week is 14 minutes, then 18 minutes, then 22 minutes, and so on. So to write a formula, this is arithmetic, so a sub n is 10 plus 4 times n minus 1. We're adding 4 minutes for every week except the first one. And then we want to know how long her run is going to be 8 weeks from today. So a sub 8 is 10 plus 4 times 8 minus 1. A sub 8 equals 10 plus 4 times 7. 10 plus 28, 38. So her run will be 38 minutes if she maintains this trend. All right, that brings us to the end of our section for today. Thanks so much for watching, and have a great rest of your day.